This is from lesson number 6 and a cool down called Analyzing Graphs. So graphs are useful for comparing relationships. Here are two graphs representing the amount of caffeine in person A and person B in milligrams at different times measured hourly after an initial measurement. These graphs can reveal some interesting information about the caffeine in each person over time. First of all, at the initial measurement, or where time is equal to 0, which is no time has passed since we first measured, this person has 200 milligrams and this person has 100 milligrams. So we can compare the starting points. We can also compare the growth or decay factors. If we take a look at person A, it goes from 200 to 160 milligrams, and if we want to figure out what our growth factor would be, or decay factor, we just divide that out and we get 4/5. So 4/5 of the caffeine is left after one unit of time. I don't know if it's a minute or an hour. Anyway, 4/5 is left, which means that they are processing or losing 1/5 of their caffeine for each hour, I guess. If we look over here, it goes from about 100 to 90 milligrams, so that has a decay factor, not growth, decay factor of about 9/10, which means that after each hour, 1/10 of the caffeine in their body is being processed and eliminated. So 1/10 is a much smaller amount that's being lost compared to 1/5. Or if you divide both of these out, actually this comes out to be 0.8 and this comes out to be 0.9. So this has 80% left, this has 90% left after each hour. So even though this person started off with twice the amount of caffeine, they ended up with a lower amount because they are processing and eliminating caffeine faster than this person over here. Let's take a look at the cool down then. This graph represents one of the following descriptions. Which one do you think it is? A phone loses 4/5 of its value every year? If it loses 4/5 of its value every year, and we started at 1200, how much of its value would it lose? You could either figure out 4/5 of 1200, or you could keep in mind that if you're losing 4/5, that you're holding on to 1/5, you could figure out what 1/5 of 1200 is and see if this number, this next dot, could represent that. Number of stores a company has triples approximately every 5 years. Wait, triples? That's going up. This is this? Camera loses 2/5 of its value, meaning it holds on to 3/5, which is slightly more than half of the value. It would have a little more than half of the value after each year. Take a look at these three descriptions and see which one you think matches up with this graph up here, and explain how you know the graph represents the descriptions you chose. Make it specific. Give me actual numbers. Calculate a decay rate. Talk about whether the graph should be increasing or decreasing based on the scenario. Let me know if you have any questions.